So I just want to kind of introduce you to a couple of things which you might have observed, okay? So first off, some of you tried sticking negatives out the front, okay? So what did the negative do? Flip it in which axis? Yeah, flipped in the x-axis. So in other words, if this was your graph, y equals x squared, there you go, then y equals negative x squared would just be mirror image. Flip it upside down, okay? Something like that. Is that okay? Yeah. Okay, now did anybody manage to move it left and right? I know that group did. Megan and Tiffany, you did, didn't you? Girls, you did as well. And York, did you manage it? Not quite. Okay, so if you haven't quite managed it, can you have a go at it now? Can you try typing in y equals, and then use some brackets, y equals x plus 2 all squared, okay? Okay, can you try typing that into your graph? Okay, so what do you notice? First question is, has it moved it left or right? It's moved it left, good. So it's moved in that direction. How many units has it moved in that direction? How many? It's 2, right? Yeah. Just check your resolution. So yeah, it's basically picked this graph up and moved it to the left by 2. It's a rubbish drawing. Let me try that again. There you go. So it's basically picked that graph up and moved it to the left by 2. Okay. So we would say this is a translation. Well, if this was in the y direction, so this one has to be in the, good, x direction by 2 units. Now just pause for a second. We're not yet doing transformations of graph. We will, but I'm kind of introducing it here a little bit. This is weird, right? Have a look at this one, y equals x squared plus 5. We said this is a translation in the y direction, fine, by 5 units. In other words, we're grabbing that graph and moving it upwards by 5. This made sense because it was a positive 5, right? And this one, you're like, okay, I'm changing the x, fine. It's just about where I put the brackets, that's fine. But what do you expect it to be? Do you reckon it's going to be 2 to the right or 2 to the left if you hadn't seen this? Yeah. It's 2 to the right, yeah? That would make more sense because it's positive 2. But it's not. You can see here it's being moved 2 to the left. Now, I'm not going to go into it yet because we will meet it, but you might want to have a think and say, huh, I wonder why that is. Okay, I wonder why that is. Yes, so you can either just accept, oh, because it is, it's just a bit awkward, but there is actually a reason why this does make sense, why it has to be moved to the left and not to the right. I'm not going to give you the answer yet, I will give it to you in a few weeks' time, but maybe think about why that might make sense. Okay. Could somebody tell me, in fact, let me create a bit of space on here. What do you think the graph y equals, let me write this down, y equals x plus 3 all squared, take away 4. What do you think that graph is going to be doing? Okay, so whilst I'm rubbing the rest off, have a think. By the way, does anybody know the special name for this quadratic U-shaped graph? Parabola. Good, it's a parabola. So this U-shaped graph here is called a parabola. And in fact, this describes quite a lot of motion. For example, if I drew this graph the other way up, so it's a sad face parabola, okay? For example, if I throw my pen up in the air and it lands, it's quite an expensive pen, so I wish I hadn't done that. But you're happy it follows that parabola, yeah? You're happy it follows that parabola shape. Likewise, people think that if they fire a gun into the air, what happens to that bullet? Well, if it doesn't hit anything, it will come down again, and it actually has killed people in the past. So if you fire a gun in the air, it does actually kill people anyway. Yeah, so this kind of shape, this parabola shape, it's kind of common in nature as well. Okay, but what do you think this graph is going to do? Good, so you're seeing the x plus 3, and you're going, haha, I think it should be 3 to the right, but I know better, it's 3 to the left. Okay, so it's a translation to the left, left by 3. Okay, so translation to the left by 3, what's the negative 4 doing? 4 down, right? 4 down. So in other words, if this was my original y equals x squared graph, that's my graph y equals x squared, okay? It says, right, move to the left by 3 and move 4 down. So I'm expecting my new graph to be about there. Does that make sense? Yeah? Obviously, this isn't drawn exactly. What's the coordinates of that vertex then? So the coordinates of the vertex of my y equals x squared graph was 0, 0. What's my coordinates here? Does that make sense? Yeah? Good. Excellent. So hopefully that's given you a bit of an introduction to like how the parabola works. Can you see that leaving something in this form is really, really useful because you're able to see exactly what's happened to this y equals x squared graph? Does that make sense? However, we hardly ever get given something that looks like this. Hardly ever. Okay? Instead, we get given it in expanded form. So could somebody expand this graph out for me? Or expand this equation out for me, rather. Good, good. So plus 9, take away 4, which means you get x squared plus 6x plus 5. How did you get that? How? Why is it not? Because if you look at this, some people would say, okay, x plus 3 all squared. Huh, I know, it's just x squared plus 3 squared. Why? What does squaring mean? Multiply by itself. So if I take x plus 3 and square it, it means take x plus 3 and multiply by x plus 3, multiply by itself. Okay? And now you're going, huh, this is a little bit more going on here. How do we expand something like this out? We have looked at this. Fatima, how do we expand something like this out? Okay, fine. So you imagine there's 2 people. In fact, let me draw this out. Imagine there is Mr. X and Mrs. 3. Okay? And they're going to visit people in a house. So they are going to visit Mr. X and Mrs. 3. All right? Okay? Now, obviously, if you go and visit someone in a house, it's rude if you don't say hello to everyone, right? So Mr. X has to say hello to everyone in here. And Mrs. 3 has to say hello to everyone in here. So what does that mean in terms of brackets then? Well, I'm literally saying this X has to visit everybody in the second bracket. Okay? Now, how are they being visited? What's the symbol going on in between those 2 brackets? Multiplication, right? There's a multiplication going on in there. Yeah? So I'm saying X has to visit X by being multiplied together. So what's X times X? What's X times positive 3? Yeah, and it's positive 3x, which is why we write a positive in front. Does that make sense? So that's Mr. X going to visit everyone. Let's do Mrs. 3. So Mrs. 3 has to visit him, and she has to visit her. Okay? So what's 3 times x? 3x. Now, is it positive or negative? It's positive, right? Because positive times a positive. And what's positive 3 times positive 3? Positive 9. Good. Okay, and then finally, we can just simplify this together to get x squared. How many x's have I got? How many? 3x and 3x, 6x, good. Plus 9. Is that okay? And then, of course, you've still got take away 4 at the end. So you say, okay, 9 take away 4, I can manage that. That's how you get your 5. Is that clear? Do some more practice. We'll be fine. Okay. So this is usually the form that we get given it in. Okay, so we usually get given it in this form here. Okay. Now, you take a look at this and you compare it to this. If I showed you that, you'd be like, oh, I'm on this. This is just 3 to the left and 4 down, right? If I show you this, who knows, right? So the question is, how do I go back in this direction? Now, we're not going to do it today, namely because there's only 6 minutes left. Okay, we will meet it though. It's something called completing the square. Great, so some of you already met this before. Okay, so completing the square is all about taking this and getting it back in this form, but we're not going to get there today.